So we're on to the final of the short questions, question 6. Now, question 6 is a sequence question and a little bit of an abstract one. Again, as we often see with this, the mathematics aren't too difficult, but finding your way to do the question is tricky. So a sequence of numbers, u1, u2, u3, all the way up to un is given by this formula. General term un is equal to 3 times 2 over 3 to the power of n minus 1. So that is the general term of the sequence. It asks us to find the first 3 terms of the sequence. So that's relatively easy in that u1, you're just putting in 1 for n, and you're going to get 1. u2, you're putting in 2 for n, you're going to get 1/3. And u3, you're putting in 3 for n, and you're going to get minus 1 over 9. So those are the first 3 terms, and you have 5 marks for that. So that's, a kind of introduction to the question. Show that un plus 1 is equal to 2 times 2 over 3 to the power of n minus 1. Now, a number of students, will find that they're just not sure what to do with this. But again, if you don't know what to do what you know. So what we know is that if un is 3 times 2 over 3 to the power of n minus 1, well, just like a function, where you had n, you're now going to put in n plus 1. Okay? So where you had n, you're going to put in n plus 1. So it's as simple as that in many ways, but that is enough to throw people off. And a lot of people wouldn't just think to do that. Once we do that, then again, we're going to use our laws of indices. And again, we know that if we have like x to the power of, I'm just going to say y plus 2, I can say that's x to the power of y times x to the power of 2. So similarly over here, I can say that I can split this part up, the n plus 1, so I can say 2/3 to the power of n plus 1 can be written as 2/3 to the power of 1 times 2/3 to the power of n. And then I'm multiplying that by 3 as I was at the start. I'm still taking my 1 away. 2/3 times 3 is 2. So 2 times 2 over 3 to the power of n minus 1. And that's what we're looking to show it was equal to. And that's for 5 marks. Now, what happens oftentimes to students is they'll found that they may not have gotten that part right. And some students will throw the towel in at that stage. They kind of say to themselves, well, I'm not able to do this question. However, you actually are able to do part C without ever doing part B, or even part A for that matter. And it turns out the part C is worth the same as part A and B together. So even if you haven't got B fully correct, you can still do C. So what we're going to do here, you're saying 3 times un plus 1. So that's just what we found. So let me build up this. This is 3 times. So we just found this here a moment ago. It's 2 times 2 over 3 to the power of n, take 1. And then it's minus 2, and we have that at the top of the page there. 2 times 3 times 2 over 3 to the power of n minus 1. Okay? And we're going to show that's equal to k. So in this case, right, you're simply, in inverted commas, but like all you're going to do is multiply out those brackets and just see what happens. So in this case, when we multiply it out, so as I go through my bracket here, I'll just show you exactly what's happening. I'm multiplying 3 times 2 times 2 over 3 to the power of n. That's my part here. I'm then multiplying the 3 times the minus 1 to get the minus 3. I'm then multiplying through the bracket my minus 2 times the 2 over 3 to the power of n. Okay, my minus is still outside the bracket there. And I'm also multiplying my 2 times my minus 1 to get my minus 2 over here. Okay, so once I've done that, I'm now going to simplify down. So obviously 3 times 2 is going to give me 6. My minus 3 is still outside here. I'm multiplying my minus 1 through the bracket while also tidying up. So 2 times 3 giving me the 6, minus 1 times the 6 making it a minus 6, and then the minus 1 times the minus 2 giving me a plus 2. And look what happens. Those two parts cancel down, and hey presto, k is equal to minus 1. So like for something that seems so abstract when it's up there, it simplifies down very quickly to be obviously a very concrete answer of k equals -1, and there's 10 marks for it. And as I said, you could get those 10 marks without ever doing A and B. So that's part C. And now we're on to part D. Find the sum of the first 9 terms of the sequence correct to 3 decimal places. Well, if you remember, we had already gotten the first 3 terms. That didn't take us very long. So you could just go off and get the first 9 terms, add them up together. Or the way that would be kind of, I suppose, planned and suggested and hoped for would be that you'd identify that the first part here is a geometric series. 3 times 2 over 3 to the power of n is a geometric series. The first term would be when n is equal to 1. And the first term there turns out actually to be 2, because the 3's will cancel. So there it is, a is equal to 2. And the common ratio is 2 over 3, because that's what, is changing each time. Everything is being multiplied by 2 over 3. So now we're going to fill in our SN formula for a finite number of terms. In this case, it's going to be 9. So our first term is 2, our common ratio is 2 over 3, our n is 9. We put it all in and we can get our decimal here for the first 9 terms. But remember, that's just the first 9 terms of this part. But of course, there's a -1 in each term. So in every one of those first 9 terms is a -1. So since there's 9 of them there, we're going to be taking 9 away. We take 9 away from 5.844, and we get -3.156. That is the sum of those first 9 terms, and there's 10 marks for that. So again, even I would suggest that if you look back at it, a lot of you would have got B wrong, but you still could have got 25 marks fairly handy from this question without having to do that part at all. And it wasn't even that difficult, but I know the language can sometimes throw people off. So there's a lesson in there. Don't give up on the question, because, oftentimes you can pick up most of the marks without doing the hardest bit, or without getting it fully right, really, I should say. Okay, that's the end of the short questions. Let's go on to the long questions, the context and application.